Today on Ask This Old House.
I'm heading to Missouri to install some bypass doors for a pantry.
That's great. That's exactly what we were looking for.
I'm glad you like it.
In Future House, I'll show you how improvements to roof shingles can save you energy and make you more comfortable.
An automatic water shutoff valve can stop a flood dead in its tracks. I'll put a few of them to the test.
So you really want me to cut it?
Yes.
Oh!
So now you can see.
It's still flowing.
Right. Okay.
Is that expected?
It takes about 30 seconds to process it, but that 30 seconds is still that. Now here it goes.
I hear an alarm.
There it is. See it?
Whoa.
Okay.
Look at that.
Hi, Joel. Hi, Nathan. Welcome to Missouri.
Thanks for having me. What do you got going on here?
Well, my wife and I live here with our 4 kids, and we love this neighborhood. They're large lots. All the houses are about the same. And in fact, my in-laws live next door, and my parents live down the street, so it's nothing but a family thing, really.
Nice.
But in terms of the house, we've got a few projects going on, and we've got one in particular we need your help with.
All right, let's take a look.
Sure. Well, Nathan, welcome to the house.
That looks great. Have you guys done a lot of work here?
We have. We've been here about 7 years, done a lot of work, floors, etc.
Oh, yeah.
And we finally got to the kitchen this year. And then with all projects that started off small, we had a small apartment-sized refrigerator. All we wanted was a bigger refrigerator, but we had double ovens here, and so that led to everything else.
Okay.
New appliances, new countertops.
Oh, beautiful. You guys do granite?
No, we didn't. This is actually laminate.
Oh, it looks great.
Well, great. But what we haven't gotten to yet is the pantry.
Okay.
This used to be a laundry room, and we converted it to a pantry, and we've never really gotten a good way to close it off when we have guests.
Yeah, you definitely want to do that. You want to close those ingredients off so they're not seeing everything you're cooking with. But with an opening like this, you have a few different options. So the first option, we could do a traditional hinge door that swings out. We could do a set of bifold doors that would have a track and they would slide out. But I see you have a spice rack here, and I know that you won't be able to open those all the way.
Right.
So maybe a bypass door would work great. There's a track mounted, 2 doors coming together. You can move them both to the left or the right. You have good access to all your ingredients.
That sounds like a good idea.
One thing I noticed is you have Luan doors. And if you want to upgrade, I noticed you have panel doors in the kitchen. Would you like to do Luan or maybe a raised panel for your sliding doors?
Well, we've never really gotten to the doors yet. We do want to update those. So if we're putting something new in, I would like to match what we got here.
All right, I'll get some materials and we'll get started. All right, these are the materials I picked up for you. I have 2 6-panel raised hollow core doors.
They look great.
They're nice doors, and I also have a bypass door kit bought in a 6-foot length.
Okay.
But when I was measuring your opening, I noticed one thing.
What's that?
You have a little bit of an irregular size opening here. This is a 6-foot track. When I go back and forth, you can see you have 2 inches on one end.
But why does the 2-inch gap matter?
When we install bypass doors, we'd like to have about 1 inch of overlayment. That way, when you can't see through the doors. If I install the track as is, when you push the doors left and right, you would have a 2-inch gap right down the middle.
So how do we solve that?
To solve it, I'm going to add some 5/4 stock to either side of the jamb, and that'll pad it down the 2 inches we need.
Are we ready for the track?
We're ready for it. Now that we have our jambs padded out, I actually added a little notch up here to receive a piece of trim, and that trim is going to hide the track and also the top of the doors. Off of that notch, I have a line 7/8 back on either end, and that'll be the front of our track. Why don't you hold it up on that end, and we'll mark the holes. On your line?
Yep.
All right, let's mark the holes. You want to drill these holes out?
Yeah.
All right. All right, now that we have that tightened up, let's throw a level on it and see how it looks. All right, so we're a little bit out. I think it's enough that we should loosen that right screw up and shim it a little bit. Good. All right, I'm gonna slide these cedar shims in. And then we'll tighten it back up and check it. All right, that's good. All right, let's put a few more shims in the center. Let's put a screw in there and check it again. All right, Joel, take a look at this. These are the rollers that come in the kit. This one's for the front, and this one's for the rear. They'll screw right to the back of the door and they'll hang up inside. We need to get a door height first. So the best way to do that is just take your front roller, tuck it up inside, and I'll measure from the floor to that slight bend. All right, 79.5. Now I'll subtract a 1/2 inch for clearance underneath. We'll cut our door 79.
Now you can watch This Old House and Ask This Old House anytime, anywhere. Download our new app to stream full episodes to your tablet, your TV, and your phone. Binge on classic episodes, catch up on recent renovations, and get step-by-step help projects all around the house. And best of all, it's free. The most trusted home improvement information is now available on your Amazon Fire TV, Roku, Apple TV, iOS, and Android devices. Download the This Old House streaming app today.
These are going to get mounted on 1.25 inches in from either side. Try and hook those on the rear fin. You in? All right. This is the floor guide that comes in the kit. It's pretty simple. What it's going to do is get mounted on the floor. The doors are going to go in between, and it's going to keep the doors separated so they don't rub on each other, but also guide them along and help them stay plumb with the jamb. Now I'm going to drill a hole with a Forstner bit, and then I'll put in a finger pull, and that will make it much easier to open up the door. Last but not least, let's put in the trim. All right, Joel, give it a try.
All right. That's great. That's exactly what we were looking for.
I'm glad you like it, but a little bit of homework.
Okay.
These come with a coat of primer, so if you putty the holes and add a fresh coat of paint, it'll be good to go.
Well, thank you. This is exactly what we wanted. Nathan, thanks for coming to Missouri.
Thanks for having me.
Richard, we're talking water leak detection.
We are automatic water shutoff devices. We've been talking about this story for a long time, chasing it, because water damage is a big story in American homes, you know. And then when these things happen, they seem like they only happen when you're not there.
You can have a leak at a toilet, underneath the sink, a bathtub, and I mean, even the washing machines, when they come with shutoffs, we just don't use them.
So first generations had these little hockey pucks, and you'd put them there and only communicate locally. But nowadays, all of these technology has an app and talks to through the internet. And the only difference between the two major categories is how they sense the leak. In either case, you're going to have to install at the water main. You're going to intercede, break that water main, put it in here. Here's one here and one right here.
Yeah.
So in this example right here, they have these sensors. Now these, you can have more than 20 of these sensors, and you would put them near the wash machine, near the water heater, and the places where you would have some chance of a water leak.
And so you have to have actual water, right? There's two little probes.
That's right.
If contact is made, that alarms.
It's battery operated, goes up to the internet and goes right to this valve and shuts it off. Do you want to test one for me?
Test it as in like make a leak?
We have full water pressure on this demo right here.
Of course I want to make a leak.
Okay.
Are you kidding me?
I want you to cut this hose, cut the red one.
So you really want me to cut it?
Yes.
You sure? I don't want to hear you, complaining after I cut it. Ready?
Oh, don't. Go ahead.
Oh!
So now you can see it goes down to that sensor. Now it's going to send a signal.
It's still flowing.
Right. Okay.
Is that expected?
It takes about 30 seconds to process it, but that 30 seconds is still that. Now here it goes.
I hear
Here
an
it is.
alarm.
There it is. See it?
Whoa.
Okay.
Look at that.
So now, that is pretty good news if you were away from the building and this hose let go.
So, you know, this is discouraging, right? So some people here think, well, that's no good. But the reality is that's 30 seconds.
Oh, yeah.
If this was 3 hours or 3
Yeah.
days,
Oh, yeah.
this is nothing.
In the house I grew up in, I've talked about it before on camera, we had a wash machine hose go on the second floor, and that house was never, ever the same. Water came down for a day.
Yeah, I had a buddy whose kitchen sink when he was skiing,
Yeah.
and 4 days later.
That's right.
Yeah. So if this one senses sort of at a point of contact,
Right.
okay, that's one
Right.
category.
Right.
What's the other category?
Well, this one has no sensors. It actually, you're dying to cut it, aren't you? So this one actually learns the building. It learns how you use water. You know, it comes through here and it sees what a typical shower is, and it sees what a typical dishwasher is, and it learns the building, it learns the usage pattern in the building.
Right.
But if it sees an anomaly, if it sees that all of a sudden there's just the equivalent of an open pipe, absolutely, that's never seen before, it would then shut that water main off without any local sensors.
So it's measuring basically flow.
Yep.
It gets used to what flow should be.
Absolutely.
And if flow starts doing something it shouldn't.
Absolutely.
Ooh, can we
Okay.
test this?
You betcha. So let me take them in, I'll get it set up, and we'll do it. All right, so I've got a new hose for you to cut, and now I've installed this valve back here to replace it.
So this guy is literally learning, measuring flow, figuring it out.
Every second of every day, it sees usage patterns inside the buildings and learns the building, and then decides if it sees something. So what I've got here, I've got it in away mode, because it also, if you're going to be away for a long time, it'll sense if anything is drawn, it'll know that there's a problem, and it'll shut it off, okay?
All right, so same drill, right?
Yeah.
Just gonna snap this guy, all right, and whoa, look at that.
Okay? So with this, it doesn't have the sensor, so it's going to take a little bit longer to sense. It could be up to a minute.
The brain is measuring
That's right.
flow,
Yeah.
starting to figure out something's wrong.
Yeah.
Still unsettling to see this amount of water
I know.
go into your house.
Right.
And even though that feels like a long time and a lot of water, if this wasn't on here, this sensor, this could just keep going for hours or days.
Oh, here it is.
Ah, look at that.
Here it is, okay?
Nice.
So now, phew. So there's something unnerving about water leaking in.
So 2 different categories,
Right.
a lot in each category, so many to choose from. Thoughts on picking one?
Whatever one you pick, good. Just get one. Just get one, because it's a great saver, and the insurance companies love it because water damage is one of the biggest issues in a house.
Very cool, Richard.
All right,
Thank
cool.
you.
Want to tackle all your home improvement projects with confidence? Join This Old House Insider, a new streaming service from This Old House, the iconic Emmy-winning series that inspired a generation of home enthusiasts. Stream over 1,000 episodes of This Old House and Ask This Old House commercial-free. Watch it all in the This Old House app. And join live online Q&As with our experts. Best of all, you can try Insider free for 7 days. To join, go to thisoldhousemembership.com.
If you could take a look down on the roofs of commercial buildings like shopping centers, warehouses, and office buildings, you probably notice that most of the roofs are white, and with good reason. Commercial buildings often have white roofs to reduce the cooling load of that building, which makes it cheaper to operate and lowers its carbon footprint. Now take a look at houses. What do you see? Almost every roof has shingles that are black, dark gray, or brown. You'd almost never see a white roof on a house. The truth is, if homeowners were willing to install white shingles, they'd reduce their cooling load. But most people object to those aesthetics. What if there's a way to get the benefits of a white roof while maintaining the look of a traditional roof? I'm headed to an R&D facility that's developing just that. Hey, Todd.
Hey, welcome, Ross.
Glad to be here.
Looking forward to talk about solar effective shingles today.
Okay.
And first, we're going to start off some basics on sunlight. The sunlight is composed of a few forms of radiation, one being ultraviolet, which is a few percent.
Right, I mean, we all know ultraviolet is very destructive, causes skin cancer, and it also degrades building materials.
Correct. Next is visible light, which is a little less than half.
Right, the colors that we see from the rainbow.
Yeah. And then the third is infrared light, which is a little bit more than half, but carries a lot of the heat.
Right, I mean, that heat gets absorbed by those dark shingles, and it gets hot up there.
A dark roof and sunlight can get up to 180 degrees Fahrenheit.
Yeah.
Okay. And what we're trying to do is actually reflect some of that infrared light back and not absorb it into the house. And that's what we're trying to do with solar effective shingles.
Gotcha. Can I see some of the shingles?
Yes, let's show you how we do it.
All right.
So welcome to the lab, Ross.
This feels a lot like my college physics lab.
So you're right at home.
Right at home.
So one of the most important properties we're going to speak about today is solar reflectivity, okay, which is a measure of how much of the sunlight is reflected back to the sky. It can range from 0, being pure black material, to 100% being a pure white material.
So 100% would be everything being reflected
back.
Gotcha.
Correct. Okay. When you look at a standard shingle, this has a solar reflectivity of around 8 to 10%. Okay. Pretty standard for a dark material. A black shingle can have around 3 to 5%.
So it's really low.
Very low.
Okay.
When you actually design solar reflective shingles, right? We design these to have a solar reflectivity of about 20%.
So double, more than double that.
Yes, more than double has a dramatic impact on your roof.
Okay, and it looks the same.
Yes, actually we're able to get that solar reflectivity while maintaining these dark colors. Then we can take that one step further and actually use a lighter material blend, but also a specially formulated granule to take that to a solar reflectivity of 40%.
So double that.
Double that.
Wow, and definitely visually very different.
Yes, and again, a dramatic impact on the cooling of the roof.
Sure, okay. So how is it made?
Okay, so asphalt shingles are made with a couple of core ingredients, one being asphalt, and the second being fiberglass. We actually use the asphalt and fiberglass mat to create this reinforced substrate, which then accepts our granules.
Gotcha.
For our granules, we use crushed rock, and we coat the crushed rock with colored pigments to make colored granules. Okay?
Got it.
We then take those colored granules, blend them together, and deposit them on the surface to create our granule surface, which gives us the look of our shingle.
This process is the same, whether you're making a conventional shingle or a solar reflective one. The difference is, on the solar reflective shingle, the granules have a reflective coating. This gives you the same overall look from the ground, but more than doubles the amount of infrared energy being reflected. In order to boost that solar reflectivity even higher though, Todd's team had to change the way they manufacture those granules.
We can actually start with the base rock, put our first white coating onto that base rock, which adds that highly reflective layer onto the rock. On top of that coating, we can add a colored coating with our pigments. Okay? Any infrared light that passes through the color coating will then reflect off of that white coating to give it that boost in solar reflectivity.
On a highly solar reflective shingle, the coating on the granule is infrared transparent, so infrared energy from the sun will pass through that colored coating, hit the white layer underneath, and reflect much of its energy back to the sky. It's this multi-layer coating that allows for significant gains in solar reflectivity. Once they've developed the formula in the lab, it's time to prototype and test.
So Jen will use the heat gun to heat the asphalt in order to accept the granules hot. And we do this under a timer in order to get the right heating profile on the asphalt substrate.
How long is that?
It's about 48 seconds. Jen will then take the granules and pour them onto the top of the asphalt substrate just to coat it. And then she'll use a weighted roller to roll the granules into the asphalt substrate. Jen will then shake off the excess granules, and then we put this into a press and press it hot under pressure for about a minute to ensure the granules are embedded in the asphalt substrate.
It's pretty precise.
Yes. So now, Ross, we're going to measure some of our samples to measure the solar reflectivity. Okay. So what we have here is a solar reflectometer. We'll put this on our first standard shingle. What it does is it sends diffuse light through the sample and then measures the reflection of that light back.
Yep, 0.08.
8%. Okay.
Right.
And then we'll look at a solar reflective shingle. So about 22%. Okay. And then we'll look at a highly reflective shingle. So this is about 44%.
Got it. And this is the one that has the specialized coating.
Correct. Okay. So this is one test we do, and let me show you some other tests we do. Okay. So here in this lab, we actually do accelerated weather testing for building materials. Our roofs in particular need to last a long time, 20 to 30 years on the lifespan of a roof, under some pretty harsh conditions.
Yeah, I mean, roofs, you got wind, you got rain, you got snow, you got hail.
Exactly. So we need to use tools to simulate those conditions to accelerate the testing, because it's unrealistic to test over 20 years.
Sure.
So we're going to have Olivier prepare some samples of shingles. These tools actually have a number of features. This one uses UV lamps to simulate the intensity of the sun, 2 times the intensity of the sun at noon.
Oh yeah, you can see it. Look at the blue light.
And this actually gives us that high intensity to really look at how UV will age the different components of the shingle.
So the UV is actually degrading the shingle.
Yes, I mean, it's sunlight generating heat, but also degradation over time.
So how long will a test like this run for?
With this testing, we're actually putting UV sunlight for about 48 hours on the sample. However, we can do various hours. For more longer times, we'll do thousands of hours to simulate years of exposure.
Right, so this test is typically maybe days and potentially a month.
Yes, exactly, or longer.
Got it.
So while the UV lights are on, we're also heating the chamber, and we heat the samples up to about 140 degrees Fahrenheit. Then the lights are going to come off. We're going to actually put a mist onto the sample. That mist actually adds moisture to the sample as part of the degradation, but also a thermal shock onto these samples that would experience in a natural environment to really get that realistic condition. Then after the spray cycle, the equipment's going to have a heated water pan to actually put a moisture or condensation onto the samples, which simulates similar to having dew onto a sample in the morning, actually. That moisture impact and moisture effect onto the sample.
Right, so you're adding relative humidity to the chamber.
Exactly. And after the first UV cycle, we then actually do a soiling test. We take the soiling solution, which consists of your normal pollutants, dust, clay, and sediments. We actually put this into a pressurized chamber. We pressurize the chamber about to 20 psi, and then we mist the solution over the sample, which provides that mimicking of the soiling in the natural environment. They go back into the UV chamber for another cycle, and then we can test for the age solar reflectance of the shingle.
Gotcha.
And then beyond this testing, we do other standard tests for shingles, including fire classification, and these shingles are rated to Class A fire rating.
That's great.
Right.
It's amazing to see the R&D you guys are working on. It's such a common building material. You know, what is the cost premium like for technology like that?
So for basic solar reflective shingles, it can be about 10% premium over conventional shingles. But as you increase performance, a high performance solar reflective shingle can be 2 times the cost.
Got it. I mean, it's interesting because I used to live in Germany, and when I worked there, we were studying how to basically absorb as much of the solar radiation as possible. Because we were heating buildings, we were trying to do solar thermal collectors for hot water, and you guys are doing the exact opposite. You guys are trying to reflect that energy.
Yeah, in this case, when you think about the US and its climate zone and this application, we want to remove as much of that heat as possible from heating the building or heating the home. So we're not putting that energy cost into cooling.
Great. Well, thank you, Todd, so much for the tour.
Okay, thanks for coming.
Keep up the great work.
Okay.
Nice piece, Ross.
Yeah.
You know, when I hear 20 to 40% increase in solar reflectivity, that kind of gets my attention. But it's got me wondering, like, how does that translate into actual savings? Do I have to run my air conditioning less, and how much less?
I mean, well, of course it depends.
Right.
So if we focus on the highly reflective shingle, the one that looks more white at 40%, if that's used in a heating dominant climate like where we are here in the Northeast, you're not going to save that much. Right. But down in Arizona and Florida, you're absolutely going to save. And typically you're going to save 10 to 15% on your cooling costs.
Gotcha.
And if you go with the middle tier one, the one that's 20%, you're going to save a little bit less.
Right, the savings goes down accordingly. Gotcha.
Makes sense. Makes sense. But you know, you always bring us these fancy innovations in the building, and you know, I'm not, and it always comes with a steep learning curve, and I'm not into that, all right? What I do like about these shingles is it's the same installation process. So my guys installing a shingle like that won't know that that shingle is benefiting
The process
the homeowner.
doesn't change.
Right. But I also like the idea of it's a lighter shingle. I think of that shingle not getting so hot, so it's going to last longer for the homeowner.
Yeah, those roofs heat up and they start to degrade quicker, right?
Absolutely.
Cool. All right. Well, hey, you sold pops. Nice job. All right. Well, we'd love to hear from you, so keep those letters and those emails coming. So until next time, I'm Kevin O'Connor.
I'm Ross Trethewey.
And I'm Tom Silva.
For Ask This Old House. Thanks for watching. This Old House has got a video for just about every home improvement project, so be sure to check out the others. And if you like what you see, click on the subscribe button to make sure that you get our newest videos right in your feed.